Welcome to the deep dive. So as we're kicking off 2025, there's a huge buzz, right? Everyone's talking about running AI models locally, like right on their own computers.
Oh, absolutely. The interest is just exploding. And it makes sense. You get better privacy, things run faster because there's less lag. And honestly, it can save a lot of money compared to relying on the cloud all the time.
Exactly. Lower latency, cost savings, big wins.
And what's really making this possible now, I think, are things like model optimization. You hear terms like quantization.
Right, that makes the models smaller, more efficient.
Precisely, without losing too much of the accuracy. And then you have things like NVIDIA NIM, these pre-built microservices that developers can just grab and use. It makes powerful AI on, well, surprisingly small machines a reality. It's a real game changer for access.
Okay, so that's our mission for today's deep dive then. We're going to try and give you the shortcut to understanding these cutting-edge cell-format AI platforms and GPUs.
Yep. We'll focus a lot on NVIDIA because they're making big moves, but also look at, what the competition's doing.
And crucially, helped you figure out what hardware might actually work for your needs. So let's jump in. Where do we start with NVIDIA?
Well, when you talk about AI on the desktop, NVIDIA is definitely leading the pack. At GTC 2025, they announced the DGX Spark. You might remember it as Project DGX.
Ah, DGX Spark. Okay, they're calling it the world's smallest AI supercomputer. That's quite a claim.
It is bold, isn't it? But it kind of shows you the direction things are heading. It's about the size of a Mac Mini, believe it or not.
Really? That small?
Yeah, and apparently very power efficient. But the key number is the performance, up to 1 petaflop of AI compute.
1 petaflop. Okay, break that down. What does that actually mean for someone wanting to run AI locally?
So that power comes from the NVIDIA GB10 Grace Blackwell superchip. 28 gigs of unified memory. And basically, it means this little box can handle generative AI models, like large language models or image generators, up to maybe 200 billion parameters.
200 billion parameters on your desk.
Running complex stuff locally, no cloud needed. And the estimated price they floated was around $3,000.
Wow, that really does put serious power within reach.
It democratizes it, yeah. And if you need even more power, there's the DGX station. That's their bigger desktop solution.
Right, the step up.
Yeah, uses the GB300 Grace Blackwell Ultra desktop superchip. We're talking like 20 petaflops and nearly 800 gigs of memory. That's for really heavy-duty professional AI work.
Okay, so those are the dedicated systems. What about GPUs for people building their own PCs, the new GeForce?
Right, the NVIDIA GeForce RTX 5090, that's the new consumer flagship based on the same Blackwell architecture. It's pretty beastly.
Specs.
Okay, so 21,760 CDA cores, massive. And crucially for AI, 32 gigabytes of GDDR7 memory.
32 gigs, that's a lot of VRAM, essential for those bigger models, right?
Absolutely. And it pushes over 3,300 AI TOPS, that's tera operations per second, basically a measure of its raw AI calculation speed.
So running something like, say, LMS70B locally becomes much smoother, or complex image generation.
The RTX 4090 with its 24 gigs is still fantastic. And if you're on more of a budget, the RTX 4060 Ti now comes in a 16 gig version, which is really helpful for AI.
And for pros, the Quadro line.
Yeah, something like the Quadro RTX 8000 gives you a huge 48 gigs of memory for really demanding professional visualization or AI training tasks.
Okay, so NVIDIA's got a strong lineup from top to bottom. How does the competition stack up against all this? Is anyone offering a direct alternative to, say, the DGX Spark?
Not really direct equivalents to the small integrated systems like Spark or Station, but others are definitely in the game. Look at AMD. Their Radeon RX 7900 XTX has 24 gigs of VRAM, which is competitive.
Okay, so hardware-wise, it's capable. What about the software, ROCm?
ROCm is AMD's software platform. It's definitely improved a lot. It's getting better all the time, but it's generally seen as less mature than CUDA. The library support, the developer community, CUDA just has a big head start.
So maybe a bit more work to get things running on AMD sometimes.
Potentially, yeah. Though for certain open source projects, it can be a great, sometimes cheaper alternative, just maybe requires more tinkering.
Got it. And Intel, Apple.
Intel has their Arc GPUs, like the B580. It's okay for lighter AI inference tasks, but doesn't have the same punch for heavy lifting. Their really powerful chip, Gaudi 3, is aimed at data centers right now, not really desktop.
And Apple's M-series chips, like the M4.
Super energy efficient, great for running lighter models on a MacBook or Mac Mini, using their Metal API for optimization. But again, not designed for really heavy AI training or running the absolute largest models. They're optimized for a different balance of performance and efficiency within that Apple ecosystem.
So it really comes back to NVIDIA's software and those dedicated platforms solidifying their lead, especially in this small format, high power space.
Yeah, I think that's fair to say right now. That combination is hard to beat.
Okay, so if someone listening is thinking, all right, I want to set up for local AI. What are the absolute key things they need to consider when choosing hardware?
Number one is VRAM video memory. Think like 8 GB minimum for maybe small experiments, 12 to 16 GB for medium-sized models, and really 24 GB or more if you want to run the big stuff or do some training.
Okay, VRAM first. What else?
AI compute performance usually measured in TOPS. More TOPS generally means faster processing for AI tasks. Then, software support, which we've talked about, SCUDA compatibility, is a big deal for access to frameworks and tools.
Makes sense.
And finally, of course, budget. That's always a factor.
Right. So could you give some quick recommendations based on use case, like who should buy what?
Sure. So for beginners or hobbyists just getting started, maybe look at an RTX 3060 with 12 GB or that RTX 4060 Ti with 16 GB. They offer a good balance.
Okay. And for people doing more serious work, researchers, developers?
Then you're probably looking at the new RTX 1590 with its 32 GB, or if the budget allows and you want that integrated system, the DGX Spark.
Gotcha. Professionals, small businesses needing serious power.
That's where the Quadro RTX 8000 with 48 GB comes in, or for the ultimate desktop power, the DGX Station.
And for the Apple fans.
If you're already in that ecosystem, a Mac Mini or a MacBook Pro with the M4 chip is your best bet for running optimized lightweight models efficiently.
Great breakdown. So recapping the whole thing, it feels like in 2025, NVIDIA is still very much leading this push for powerful local AI, especially with compact options like the DGX Spark and the top-tier RTX 5090, all really boosted by that CDA ecosystem.
Yeah, that sums it up pretty well. The hardware is getting incredibly powerful and surprisingly small.
Which leads to a final thought for everyone listening. With this kind of supercomputing power becoming accessible, almost desktop standard, how might that change things? How could it reshape innovation, maybe improve your own data privacy? And what cool new projects could you actually start now that this power is within reach?
It really opens up possibilities.
Definitely something to think about. Thanks for joining us on this deep dive.